Assalamu alaikum, welcome to everyone. This is my first lecture of vector. So this is just 2 in 1. Why 2 in 1? Because this is the second chapter of physics first paper and second chapter of math first paper. Okay, so if you can learn this chapter clearly, then you can get 2 chapter just in 1. Okay, so let's start. Now at first we should know what is vector or what is vector quantity and what is scalar quantity. Okay, so what is vector quantity? Vector quantity versus scalar quantity, scalar quantity. Okay, what is vector quantity? I mean, what is vectors? Okay, what is vector quantity and what is scalar quantity? Okay, suppose time. Okay, we can just measure time, but time has no definite direction. Okay, so again, if your mass is 40 kg, right? I mean, if your mass is 40 kg, so you can just measure your mass. Okay, but you can measure its direction. I mean, you are 40 kg or you are 50 kg, but in which direction? This is totally funny. Okay, so mass is not vector quantity. Mass can be defined as a scalar quantity. But if your displacement is 4 meter, I mean, if your displacement is 4 meter from A to B, then you can say your displacement is a vector quantity, because its definite direction is defined. I mean, if your displacement is 4 meter, then you can measure its value or magnitude and direction, definite direction. That is why displacement here, displacement is a vector quantity. So we can define clearly that what is vector quantity and what is a scalar quantity. Vector quantity is a quantity, vector quantity is a quantity that has both magnitude and direction, magnitude and direction. Okay, so vector has both magnitude and direction, but scalar quantity has only magnitude but doesn't have definite direction. Okay, so we can clearly say, I mean, this is the simplest definition of vector quantity and scalar quantity. Okay, so if you say vector quantity has definite direction and definite value or definite magnitude, okay, fine, but scalar quantity doesn't have a specific direction but has definite value or definite magnitude. Okay, now we should learn a small a simple trick that will be very helpful to remember what is vector quantity and what is a scalar quantity. Okay, now we should apply a trick. This is not serious matter, but if you can apply, then you can remember vector quantity or scalar quantity easily. So I am writing something different. So let's start. I mean, phi mu dit wave. Phi mu dit wave. This is just a trick. I mean, simple trick to remember vector quantity. Please don't take it seriously, because this is not so-called definition of vector quantity. So let's start. I mean, here force, F defined as force. So force is a vector quantity. So force, general force, it can be centrifugal force, it can be centripetal force. Force can be also centripetal and centrifugal. Okay, centripetal force and centripetal force. Centrifugal force. Okay, centripetal versus centrifugal. So force can be also centripetal and centrifugal. I will discuss these types of force in Newtonian mechanics. Okay, so we should wait for proper definition or I mean proper description. Okay, so I will not discuss everything here, because we are just discussing vector quantity. So if I should discuss everything, that will take really great time. Okay, so I will not waste a variable time here. just behind the description or specific description. So just I will discuss what are actually vector quantities. Okay, now F force, here F is force, so force has both magnitude and direction, so force is a vector quantity. Phi mu A here A defined as acceleration is a vector quantity. Now I means intensity, so intensity maybe electrical intensity, magnetic intensity, or gravitational intensity. There are three types of intensity in your Hsc thesis. I mean it can be electrical intensity, magnetic intensity, and gravitational intensity. So intensity is a vector quantity. Mu is movement, I mean momentum. So momentum is vector quantity. I mean if your mass is m and your velocity is v, so momentum p is the mb, so momentum is a vector quantity. So here phi mu, F defines as force, so M means acceleration, I means intensity. So you can define three types of intensity: electrical intensity, magnetic intensity, and gravitational intensity. So these three types are intensity. So intensity is a vector quantity. Okay, now what is D? D means displacement. Displacement. So displacement is a vector quantity, but don't say distance, because displacement has definite direction. Okay, but distance doesn't have definite direction. That is why distance is not vector quantity, but displacement is a vector quantity. Okay, now what is I again intensity, you can remember as intensity. And D, what is D? Again D means deceleration. What is deceleration? I mean opposite of acceleration. What is acceleration? Acceleration is a change of velocity with respect to time, and deceleration I mean this is a decreasing velocity with respect to time. Okay, now what is W means weight. Weight is a vector quantity, and wave acceleration, again V velocity. So velocity is a vector quantity. So this is a funny trick to remember vector quantities, but I will not suggest you to remember this trick. You can use your own trick. Okay, but this is my suggestion. Now these types are example of vector quantities. Okay, now there are some quantities that have both magnitude and direction, but they are not vector quantities. You will be surprised. Okay, I mean definition of vector quantity is that vector quantity has both magnitude and direction, but I am saying that I mean EPS, you know what is E? E means electric current. Electric current. So electric current is not a vector quantity. Electric current can be AC or DC, but electric current is not a vector quantity. What is P? P means pressure. Pressure has both magnitude and direction, but pressure is not a vector quantity, because in a running situation we can define direction of vector. Okay, so S means two quantity: stress and strain. They are not vector quantity. We will learn about stress and strain at chapter 7. Okay, so these are quantities that has both magnitude and direction, but you can say they are vector quantity, because in special situation we can define their definite situation. I mean simultaneously we can measure both magnitude and direction. Okay, or sometimes their direction are not specific. Okay, that is why we are these four quantities are not vector quantities at all, although they have both magnitude and direction, but we can say they are vector quantities. So this is really miraculous. Okay, now we should learn about scalar quantities. So scalar quantities, what are scalar quantities? A scalar quantity has only magnitude but doesn't have definite direction. So I mean I am again suggesting you a special trick. Okay, so MP was state wasted divergence. MP wasted divergence. So MP, what is MP? This is very miraculous matter. I mean, what is M? M mean mass. Mass is a vector quantity. No, mass is a scalar quantity. Again, what is P? P means power, or P means pressure. So pressure and power are vector scalar quantities. Okay. Now W mean here work. Work is a scalar quantity. A means area is a scalar quantity. Okay. S means speed is a scalar quantity, but velocity is vector quantity. Now E, what is E? E means energy. Okay, so energy is scalar quantity. Energy is scalar quantity. What is D? D means distance or density. Distance, density are both scalar quantity. Okay, but displacement is a vector quantity. Now divergence is a scalar quantity. What is divergence? Especially compression or refraction of liquid or gas. Okay, just like this. I mean, this is expansion of fluid. So expansion of fluid is divergence, or compression, I mean contraction of fluid is divergence. So especially I will discuss gradient, divergent and curl in this chapter. Then we can learn clearly what is divergence, curl and gradient. Okay, but here divergence is scalar quantity. So these are scalar quantities. Here I will suggest you again MP wasted divergence. This is not so-called definition. This is just a trick that will help you to remember what are actually scalar quantities. Okay, so MP wasted divergence, MP mass, P power or pressure. Now W work, area, speed, energy, distance or density, divergence. They are not vector quantities, they are scalar quantities. Okay, again there are some special cases. I mean there are some special quantities that should be remembered. I mean torque. What is torque? Torque is a vector quantity. Torque is a vector quantity. So torque is a vector quantity. Now there is another special quantity. I mean surface area. Surface area. Although area is scalar quantity, but surface area is a vector quantity. When we will learn about flux, electrical flux or magnetic flux in physics second paper, then we should say surface area is a scalar quantity, vector quantity, not a scalar quantity. Okay, so we should wait till flux, then we can clearly say why surface area is a vector quantity. Okay, now centripetal force, centrifugal force are vector quantity. Again curl, I mean gradient are vector quantities. So we should learn about curl and gradient in this chapter. I mean this vector in this chapter, I mean vector has three major parts. I mean basic plus dot multiplication and cross multiplication, part 2 parallelogram law and its application, and third part is gradient, divergence, curl. Divergence is a scalar quantity and curl and gradient are vector quantities. Okay, so this lecture is just about why vector, why scalar. I mean who are vector quantities, what are vector quantities and what are scalar quantities. Okay, so now I will suggest you to remember some special cases. Okay, here we should learn about basic, I mean core concept of vector. Core concept of vector is that we should introduce at first our displacement. I mean if your displacement is a 4 meter along A to B, I mean from A to B your displacement is 4 meter. So displacement is vector quantity here because this quantity has both magnitude and direction. But I will say you that this is not appropriate at all. Why? your displacement is 4 meter and this is vector quantity, but you are saying this is not appropriate. Then what is appropriate? Appropriate concept is that your displacement is 4 meter, but in which direction? It may be towards x axis, it may be towards y axis, and it may be towards z axis. So if I say your displacement is 4 meter, so in which direction? In positive x direction or negative x direction? In y, along positive y direction or along negative y direction, or along positive z direction or negative z direction? This is really surprising. Okay, so your displacement is 4 meter. This is not enough. Okay, so I will discuss it next. Okay, now we should define as a vector. Okay, so if you say this is just a vector, I mean if this is U and this is P, okay, so your displacement is 4 meter. Suppose I am just suggesting you now that I mean from U to P your displacement is 4 meter. So now you are denoting this vector as a vector. Okay, now what is a vector here? I mean notation of vector or expression of vector quantities. So you can use arrow sign like this one, or you can use bar sign. Okay, I mean or you can write just a bold form. Okay, so these are expression of vector quantities. So I mean at first you should know expression or notation or denoted concept of vector. I mean in which symbol we can express vector quantities. So there are majorly four symbol or 4 style or 4 custom. I mean you can use arrow sign, okay, or bar up or down, or you can use a bold form. Okay, but if you say this is a 4 meter and you are dividing this vector as 4 portion, then every part is a cap. So this is called unit vector. The vector which magnitude is just 1, that is a unit vector. So when you are using this symbol, then this is used for unit vector. Okay, now suppose this is 4 vector, so you can say a vector is equal 4 a cap. Okay, so magnitude of a cap, what is magnitude of a cap? Equal 1, because this is unit vector and its value is 1. That is why total vector can be expressed as I mean like this one, or like this, or like this, or just a bold form. Okay, but why this cap sign? Cap sign is used as I mean this is used for as unit vector. Okay, so now I again suggest you, your displacement is 4 meter, but in which direction? This is a big question for you. Okay, so generally we have 3 dimension: x axis, y axis, and z axis. So this is x axis, and this is y axis, and this is z axis. Okay, so suppose your displacement is 4 meter, your displacement is 4 meter, but in which direction? Okay, again we in our previous I mean pages you used as this, as like this one. I mean here a vector is equal 4 a cap. So every part is 1 unit, here. Okay, now from U to P your direction is from U to B and its value is 4 a cap. Okay, so a cap, magnitude of a cap is equal 1. Okay, but I will suggest you now a different scenario. I mean here I cap, j cap, and k cap. Although you know a cap, here a cap is a unit vector, but here I cap, j cap, and k cap are rectangular unit vector. They are called rectangular unit vector. I mean towards x axis, if your displacement is 4 meter, then you should write 4 I cap. I mean 4 I cap means your displacement is 4 meter but towards x axis, so 1 2 3 4, your displacement is 4 meter from O to P, your displacement 4 meter. So instead of a cap you are using I cap. Okay, so if your displacement is 4 meter towards x axis, then you should use 4 I cap. 4 I cap means every part is I cap, and every part's value is 1. Okay, now if you say your displacement is minus 4 I cap, then your direction will be towards negative x axis. I mean this towards negative axis, this is the origin and this is final point. I mean 1 2 3 4 part, every part is I cap. Okay, every part's value is 1. That is why we are using minus 4 I cap. Okay, so similarly we can say 3 j cap or 3 j cap. Suppose your vector is 3 j cap or your displacement is 3 j cap, then you should use just like this one. So this is your origin and this is your final point. Now you are just heading towards y axis, so your displacement is 3 j cap. So I mean your displacement is 3 meter or 3 j cap, so your direction will be towards positive y axis. So if you say minus, then this will be negative y axis. Okay, 3 units towards negative y axis. Okay, so just if you say your displacement is I mean 4k or minus 4k, then this your direction will be like up or down. If you use just like this one, so this is x axis, this is y axis and this is z axis. Okay, so this is called 3-dimensional configuration. So I mean this whiteboard is 2-dimensional body. Okay, you are using 3-dimensional concept, so z axis will be like this one. Okay, this is the x axis, this is y axis and this is z axis. So this is z axis. Okay, so this is third axis or 3-dimensional concept. Okay, now we will learn about 2-dimensional vector. I mean suppose you displacement in 2-dimensional concept. Suppose you are learning about a vector equal 2 I cap plus 3 j cap. Okay, suppose what do you mean by it? 2 I cap plus 3 j cap. So for this purpose we should learn about vector addition law of what is vector addition law. Suppose your displacement is from A to B and B to C. So I mean you can say AB vector plus BC vector equal Hsc vector. What do you mean by it? AB vector plus BC vector equal Hsc vector. Okay, I mean two sides of any triangle is greater than obviously third side, but why they are equal here? Because addition of vector quantities can be measured in general law. I mean just using algebraic law we can define addition of vector quantities. Vector quantities actually don't follow addition law of general algebra. Okay, so here AB plus BC equal Hsc means vector indicates easiest way. I mean if you go from A to B, A to C, or A to B and B to C, then one step means 2 steps. So this is real convenient to A to C then A to B and B to C. Okay, so this is easiest way. So that is why AB vector plus BC vector is equal Hsc vector. Okay, this is called addition law of vector. Okay, so here 2 I cap plus 3 j cap. 2 I cap plus 3 j cap means if you consider your starting point here. Okay, then your displacement is 2 I cap towards x axis, then 3 j cap towards y axis. So okay, your displacement is like this. So this is your vector A. Okay, what is the value of your vector? So this is a vector and its value is 2 square plus 3 square. I mean root over 13. Okay, so if you use a vector equal minus 2 I cap plus 3 j cap, so its direction will be like this one. Okay, I cap, I mean minus and plus, so this is not actually right. This will be like this one, minus 2 I cap, minus 2 then 3, 1 2 3, okay, like this one. Okay, 2 I cap minus 2 I cap plus 3 j cap. So I mean this will be your vector quantities, a vector. Okay, so its value will be again a vector is equal minus 2 square plus 3 square then root over 13. Okay, so for 2-dimensional this is a square of coefficient of vector quantity. So for 3-dimensional, I mean if you consider a vector 2 I cap plus 3 j cap plus 4 k cap, okay, then its value will be 2 square plus 3 square plus 4 square. Okay, this will be root over 25 29 unit. Okay, so this is my first lecture. I mean I will not describe at all anymore because this will be very long for you, but in our next video we will discuss everything, I mean step by step. So follow my channel and follow my lecture. I hope you will get something exceptional. Okay, thank you so much. Okay, Assalamu alaikum.